Hello everyone. This session would be for semaphores, like using fork and shared memory. So we'll be writing a C code to understand this concept. Imagine a single ATM machine outside a bank. Many people are standing in line. Only one person can use ATM at a time. So how do we control this? So we definitely would be needing a rule, a permission system, and that rule in operating system is called a semaphore. So a semaphore is a synchronization tool used to control access to shared resources that can prevent race conditions and ensure mutual exclusion. In simple words, semaphore is like security guard giving entry permission. So let us write code. So I'm writing using fork, that's why. So let us add the required libraries through the header files. So I will use hash include stdio.h, hash include unistd.h, and hash include std.h. Then we'll require hash include because we would be using fork. That's why sys bit dot h. So I should remove this. Then we will require because we are going to make use of shared memory. So that's why we have to use a map. So sys slash man dot h. Right. And we would be using semaphore library. That's why we have to include semaphore dot h2. Semaphore dot h. Fine. So here semaphore h semaphore dot h will be used for like semaphore functions. mman would be using mmap or function for creating shared memory. Fork would be for creating processes and wait would be for parents waiting the child. So key idea is uh, process do not share the memory by default. So we must create shared memory for the semaphore. Let us create the shared memory for the semaphore. So integer main. So let us create shared memory. Create shared memory for this semaphore rather, correct? For the semaphore. Fine. So we'll use the structure same underscore t semaphore, correct? Equal to. We'll take smaller name so that we can see the whole line here. Map. So we'll be using similar list of parameters that we used earlier. Size of. Now here we will take structure size of that structure. Then prot read pipe protection write, correct? Then map shared and map anonymous. And lastly, -1, comma 0. Correct. Now, this is very important conceptually. So we are creating shared memory region where the semaphore will live. Fine. So map shared, memory shared across processes, map anonymous, not linked to any file, and protection read and protection write or read write is permitted. So this is like placing an ATM control system in a public place, so all processes can see this. Correct. So we have created this. Now we have to initialize the semaphore. Initialize the semaphore. How do you initialize? So use a function same underscore init. And you use the variable name. This. Now here, if you see, This function is used for initializing the semaphore. Fine. Now here the first is parameter or pointer to semaphore. Okay, so here like we have the second parameter for this. So if I write here man same same init. So this is for initializing a unnamed semaphore. So here we are having three parameters: semaphore name, then int p shared. This is to communicate that it is shared between processes, and a value, so that only one process would be allowed. So how many process would be, like if you see the things detail for it. So value argument specifies the initial value for semaphore, correct? And same with your parameter. Fine. So we used one. So shared between processes. That's why we said one, and value initial value. Value one means binary semaphore. Right. The last parameter that we had, this tells it is a binary semaphore. So that we can say only one process can enter critical section at a time. So mutate like behavior. So only one person permitted inside the ATM. Fine. Now let us write the code. We'll create three processes. I equal to teacher, I equal to 0. I less than 3, I plus plus. Fine. So if fork 0, then printf double quote process %d wants to enter /n, correct, and we'll tick right its PID. So get PID, correct, and then like this is done. Fine. Then we will use like in this case. Now here I'm in this loop. I am creating three child processes. Each child behaves independently. So, but all of them will compete for the same resource. So this is our entry request through printf process %d wants to enter, correct, with /n get PID. So each process announces that I want to enter into critical section. Now we'll use same wait function. So it is like a p or wait function, wait operation in semaphore. Same underscore wait, and then you write same. So man same underscore wait. Right. So this is for locking the semaphore. So p wait function, right, like p operation or wait operation. So we are requesting the permission. Okay. Now again printf process %d. Now when permitted, so %d entered critical section, right, /n again get PID. Then we will ask that process to work for a while because it is entering into critical section. So we are simulating that work, and then again like once it is done, it should leave, correct, %d leaving the critical section, correct. Now once it is done, so another function that would be using here is same post. So release permission. So let me go back here and let me write same post. So this is unlocking, right? Unlocking. It is similar to what we have as like in this case, it would be like V or signal operation. So which increments value and wakes up the waiting process. So similarly, like what we saw earlier, operation same wait, correct, in our code, it is P or wait kind of function that we used here. Correct. Checks semaphore value. If value is greater than 0, decrements and enter. And if value equal to 0, then process waits. This is like asking security guard, can I enter? If free, allowed. If busy, wait outside. Like because of this particular function. Then we are entering into critical section. This is core idea of mutual exclusion. Correct? Like when we say entering. then we are leaving critical sections. Then we are releasing the lock by increasing the semaphore value and wakes up the waiting process. So this is like leaving the ATM and telling the guard next person can go. Fine. So when this is done, right here, exit 0 for that process. Correct. Bracket, bracket. Fine. Now the parent should wait because we have created the children's. So that's why we'll write parent for waiting purpose. I will write wait system call. Wait. So no need to use curly bracket because this is a single statement that we want to use. And once done, like the semaphore created should be destroyed. So same destroy. So if you see same destroy. So this function was used for cleaning up the semaphore so that it can free the resource. Okay, destroy and unnamed semaphore. So always important for system hygiene. Fine. Now let us just complete the code. Return 0, then bracket. So we are done with the code. Okay, now think of a system like it is a single washroom outside a classroom. So that's what many students want to use it. Only one is allowed inside. So when once one goes, when he comes back, he or she comes back, till the time he or she is not coming back, others have to wait. So when he or she comes back, leaves, that means next enters. That is exactly how semaphore is working. So let us save this code. Let us go back and then compile. Dash M32. Then you can see 3-1, 3-2, 3-3. 3-1 entered, then 3-1 lived, then 3-2 entered, 3-2 is leaving, 3-3 entered, 3-3 is leaving. So when we executed, you will see that outputs are not mixed and only one process enters at a time, and this triggers conceptual clarity instantly. Right? And this is how the critical section is accessed. So the functions that we used here, you can you see this for initialization, then this wait signal, wait operation, then this signal operation, and then you have to destroy. Correct? You have to destroy the semaphore created. So that's how you can make use of semaphore to operate upon. So semaphore initialization is important for you to understand. Fine. Thank you very much.